We are looking at our homework for Chapter 14, and in this problem we are giving a country that is currently emitting 50 million tons of sulfur dioxide, which is a pollution, which is a poisonous gas per year. And the marginal cost and benefits of reducing these emissions to various amounts lower than 50 are given on your table in your spreadsheet right here. So here's the marginal cost as we reduce more and more and more. As you can see, the marginal cost is an upward sloping function as we reduce from 40 down to 0. And marginal benefit is a downward sloping, which means we get less marginal benefit as we reduce more and more down to 0. Now, the first question is what is the intuitive reason? I mean, what is the common sense reason that marginal costs rise as emissions of sulfur dioxide are reduced? And generally, as you reduce to lower levels, you're going to have to employ or use more technology that's more expensive. So the first reduction, let's say in this case from 40 or from 50 down to 40, as you can see here or here, the marginal cost for that is only 6 million. That might just entail, that might involve installing some relatively less expensive filters. But as we get down to lower and lower levels, we're going to have to do more and more, use more and more filter technology to reduce it at those lower levels. We may even have to change our production methods. So it becomes more and more expensive as we drop down to lower levels. Now, the answer that I wrote here, now I'm going to show you answers, but please hear me out because there's going to be more. I'm going to be explaining sort of how this works as I go through. So you're not doing yourself, a good service by just freezing the video and copying the answers. I really want you to, listen to the videos, this one, and look at all the ones for that are on the Khan that I posted in the Khan Academy link, and make sure you read your book very carefully so you get a thorough understanding of how this works. Okay, so anyway, but the answer that I've written here is just basically what I said. As you get down nearer to 0 emissions, then those reductions are typically the hardest and the most costly. Okay. Question 2, what is the intuitive reason that marginal benefits decline as emissions of sulfur dioxide are reduced? Well, if you think of just anything, if you think of a smoky room where everyone's smoking, if you could cut that smoke down, if the room is filled with smoke, then you're going to get a lot of benefit out of getting half of it out of there, right? If it's just a little bit of smoke, if only one person in the whole room is smoking, and there's 100, and it's a large room, and there's 100 or more people in the room, and there's only one person smoking, telling that one person to stop smoking isn't going to give you that more benefit, unless you just happen to be standing right beside that person. So as you get down to the lower levels, reducing it from something low down to even lower or down to 0 doesn't give you as much marginal benefit as those first reductions do. Okay, so the answer that we have written here is, usually what you do first in terms of reducing a pollution helps the most, and then as you get lower and lower, the marginal gains become smaller and smaller. Okay, question 3. At what point are marginal benefits and marginal cost equal to each other What is the significance of this point? Well, it's obvious when we look at either the table or the graph that marginal costs and marginal benefits are equal when we reduce our emissions down to 20 million tons at a cost of $20 million and a marginal benefit, I should say marginal benefit of 20 million. Now don't get the marginal confused with the total, right? Because at this point the total benefit is very high here, okay? Or the net benefit, and I'm going to talk about that. But first, we can see that if we just look at the top graph right here, we can see that as soon as we reduce past 20 million tons, marginal cost becomes greater than marginal benefit. So the cost is greater than the benefit. So we want to stop here. Now the other way we can look at that is if we go down to our other graph below it, and we look at our net benefit, which is our green line here. It is maximum, and it doesn't start to actually go down until we get to 20. So we can reduce up to 20. Now, why would we not? Well, why wouldn't you might ask? Well, the net benefit is the same at 30 as it is at the 20. But if we look back up here again, we can see at that point we still a marginal benefit is way above a marginal cost. And also, if we look at total, right? Total benefit is greater at 20 than at 30. So the best place to stop here is right when marginal cost equals a marginal benefit, and net benefit right here is maximized. So this is where there's this part right here, from here to here, is where there's the most difference between marginal cost in the blue and marginal benefit. So the net here is the largest. So that's why we want to stop at 20. Okay, and the answer that I wrote in here was basically that. So you want to go up to the point. So even though you could stop it at 30, you want to go ahead and go all the way to the point where marginal cost equals a marginal benefit. That's going to give you the most benefit for your money. Okay, number 4. What is the total cost of reducing emissions to 10 million? The total cost, okay. So the total cost of that is easy to see. So it costs 72 million, right? And then what is the total benefits of reducing to 10? And that would be 112 million, okay? So what we're really getting at here is we're trying to sort of get a handle on or understand why we don't go ahead and reduce down to 10 when total benefit is still greater than total cost. So that leads us to question number 6, which is, does your calculations in questions 4 and 5 prove that emissions should be reduced to 10 million tons? Well, actually the answer is no. And why that is, let's just jump over here to our answer. Even though total benefits do exceed total cost, the fact that the benefits are higher than cost does not prove that 10 million tons is the correct goal. Total benefits are also greater than cost at emissions of 40, 30, and 20. Society should always choose where overall gains are the greatest. Net benefits at 10 million tons is less than net benefits at 20 million. So if we look back at our graph again, we can see that at 10, down here at 10, right here, you can see that net benefits are substantially lower. They're at 40 million, or actually I think it's 44 maybe. Let's look and see. At 10. No, it's at 40, yeah. Whereas at 20, if we stop at 20, our net benefits are the highest. It's 66. So that's why we don't go down to 10. Okay. Last one. The question is, why not have a law that eliminates sulfur dioxide emissions altogether? After all, this table clearly shows that there are benefits to be gained all the way down to zeros. So if we drop from 10 to a 0, the marginal benefit is $2 million. So we do a benefit. However, look at the cost over here. The cost is huge. So the cost of going down to 0 far outweighs the relatively very small benefit. Okay, so the answer that I actually wrote in here is probably the same. Reducing emissions from 10 to 0 does have some small marginal benefits. However, on the margin, reducing emissions by more than 20 million tons causes marginal losses. In other words, once we get past 20 million right here, marginal cost is higher than marginal benefit. So we do not want to go past that point. Okay. In the future, if new technologies are developed for reducing pollution, and as the marginal cost drops, it will make sense to reduce emissions further. But except for the deadliest of materials, where the cost of even very small amounts are extremely high, a goal of zero emissions typically doesn't make economic sense. Of course, that's always going to, there's so many variables. This is, I want you to keep in mind, this is, a very simplified model, making a lot of assumptions. If you were doing this for real, you'd have to look at exactly what would be the damage or what would be the danger of this particular pollutant. More than just this very simple graph. But this is the sort of a basic concept on how a country decides what to spend on pollution control and how far to go with it. Okay, so that is your homework for Chapter 14.